Howdy, everybody. It's Saturday, March 7th, and we're back on the air. This is Nighttime Mathematics Radio, where if you have any math questions, you can just tweet them to us live on Twitter. We'll try to answer them here on the air. So the format's what it usually is. Feel free to head on over to Twitter, see where things are. We'll be watching for your tweets, and we'll try to answer your questions as they come up. So if you're new to the show, this is a show where we try to help you with math on the air. So the plan is you tweet your math questions to us on Twitter, and please tweet math questions. I'm confused about math may be true, but it's not something I can really answer. Then I'll try to answer them right here on the air. For right now, let's sit back for a few minutes and listen to some of the very best beats that Apple gives you for free. So once again, this is Nighttime Mathematics Radio. The plan here is that you tweet me at @NightMathRadio on Twitter, and I'll try to answer math questions as they come in live on the air. For the moment, let's take a look at a kind of question that was being asked over the week through other channels. That's a question about U substitution. Now, U substitution's one of the first really tricky forms of integration you have to deal with when you're taking a calculus class. The idea of U substitution is that basically you're trying to run chain rule backwards. So let's take a look at this for a second. Now, I think we all know standard chain. Oops, let me get my document camera in this sort of reasonable state. There we go. I think we all know chain rule from differential calculus, and there it's pretty easy, right? You have the dx, for example, of sine cubed x, for example. You say, well, how do I do that? And the answer is, well, that's a composition of two functions. You're taking a sine first, and then you're cubing it. So how do you do that? Is you first take a derivative of the outermost function. The derivative of something cubed is 3 times that thing squared, times the derivative of that thing. And the thing here is sine x, so you have to put a cosine x at the end. Now, u substitution is exactly this, except done backwards. Instead of being given the nice derivative in the beginning and having to unroll it using chain rule, you're given the final form, and you have to recognize it as the result of chain rule. So, for example, suppose we have an integral of sine to the 5th x cosine x dx. How are we going to handle that? And the answer is, you can sort of see by looking up above. Where for u substitution, you say, I'm going to define a new variable u, which will be easier to do, I think. And then I'm going to take a derivative of it to find out what du is. Well, the key thing here is, looking at this thing, you see a sine to the 5th x. You say, I don't know how to integrate sine to the 5th, but I do know how to integrate x to the 5th. So what if I say u is equal to sine x? Because if that were my variable, then what I would have there is u to the 5th, and I know how to integrate u to the 5th. So to see if that's plausible, I have to take a derivative of this to get the chain rule part, cosine x dx. I say, great, there it is, right there. And as you get more practice with u substitution, usually that's actually where you start. What'll happen is, as you go along, you'll start doing your u substitution problems by noticing by really seeing the du sitting right there. You see that cosine x dx, that immediately should tell you, oh, I can make u equal sine x, and then I've got a du sitting right there for me. So plugging in the substitution, that's the integral of u to the 5th. That's sine x is u, so sine to the 5th x is u to the 5th du. And that we know how to take an integral of. That's just 1/6 u to the 6th plus c. And now we have to remember, that's great, but our problem didn't involve u, it involved x. So now we have to plug back in. This is 1/6 sine to the 6th x plus c. And that's our final answer. And that's really the key idea behind u substitution. When you're doing a u substitution, you're basically looking at the integrand and saying, does this look like the result of a chain rule? And if this looks like the result of differentiating using the chain rule, then great, you can actually do a u substitution. If it doesn't, well, you can't. And the problem is, well, how do you recognize this in practice? And the answer, unfortunately, is this. The way you recognize it in practice is practice. This is why calc books have giant, giant exercise sections. There's no way you're going to recognize this in practice without just doing problem after problem and seeing what u substitution can do for you. This is Nighttime Mathematics Radio. So, once again, if you have any math questions for me, feel free to tweet them at Night Math Radio on Twitter, and I'll try to answer them here live on the air. For now, it's back to some of the best songs Apple provides for free while we wait for Twitter. Good evening, everybody. Welcome back to Nighttime Mathematics Radio. This is a channel where we try to help you with math problems on the air. Once again, if you have any math problems, feel free to tweet them to @NightMathRadio, and I'll try to answer them right here. It's a bit of a quiet night, which isn't terribly surprising for the night before daylight savings time starts again. We're all going to have to wake up early tomorrow morning as it is. So as things stand, let's bring the show to a close. This has been Nighttime Mathematics Radio. We'll be back next week, Saturday at 10 p.m. Pacific time. If you have any math questions, feel free to tweet them to NightMathRadio. You can do that during the show, and I'll try to answer them live on the air. Or you can do that at any time, and if I happen to spot it, I'll try to help you out over Twitter. But since the character limit is a bit difficult with math, and it's a lot easier to use a notepad, it's better to do it on the air. This has been Nighttime Mathematics Radio. See y'all next week.